Hi, welcome to your Math Resource Showcase. I'm Amber Soto, and this week we have been exploring that beautiful place where math and art come together. And I had a resource that I wanted to share with you today that I thought was pretty cool, but the title of it's kind of long, so we're just going to pop it here in Google so you can read it for yourself. If you need to pause to write it down, you can. It's smithcurriculumconsulting.com/math-in-art, and then another slash to close it off. So that's smithcurriculumconsulting.com/math-in-art. And let's go see what's there. It's got, they say 18 STEAM projects, but there's some really, really cool stuff on here. So anytime they show a picture, underneath will take you to a place to show you how to do it. So this one's an ordinary tangle of triangles, or orderly, sorry. This one, the Pi Skyline, is one I actually wanted to do with you this week, but because of the holiday, I had to bump some things around. But please check this out. The idea is you take pi, so 3.14159, et cetera, et cetera, et cetera, and you graph each of the numbers like a bar graph. So you can see here, this first one is 3, and then 1, and then 4, and then 1, and then 5, and then 9. And so you graph all the numbers as far as you want to go. And then you create it like a city skyline, and you give a background, and you use that art, allow the creativity to happen there, and it's beautiful. And really, you don't have to use just pi. You can really use any number. You could use maybe a date that's significant to you, or you could use, a moment in time that something happened. There's so many different things, as long as you're practicing with that idea of how to graph particular numbers and then bringing the art of the skyline in with it. I love that one. It's one of my favorites. There's compass painting, there's symmetry activities with self-portraits, tessellations are always fun. But the one I'm going to do today right now is called the Pythagorean Snail, and it plays a little bit with the Pythagorean theorem. Now, you could click on here and it'll give you different instructions on how to do it, but I thought it would be easier to just make a video to show you, to allow me to talk you through it while doing it. But I do want to put a couple disclaimers. There's a couple places I keep calling it a Pythagorean squirrel instead of snail. There's a couple places where my pen slips and my ruler, so if you do it in pencil, it's probably better. So this is not the cleanest version, and I apologize, but you get the idea of what to do. Okay, so I'm going to allow myself to take it away. All right, so today we're going to work on creating a Pythagorean snail. So the idea is you start with a right angle that both the lengths are the same size. Well, you're thinking to yourself, I don't have a compass, how do I do a right angle? Well, there's several ways you can do it. You can do the angle of your ruler. If you don't have a ruler, I suggest, and this is what I'll use just for the sake of showing you how it could work, taking just the corner of any paper and using that as your measurement for your 90-degree angle, okay? So I'm gonna start dead in the center of this paper. Okay, and I'm going to make my 90-degree angle in this direction. So you start by putting a point at the center, and then you draw along the 90-degree angle. Now, how long are we going to make this? It really doesn't matter. You can pick whatever length you want. I'm going to do 1 inch just because I think that 1 inch is probably the easiest to do. And so what I'm going to do here right now is I'm going to measure 1 inch along this paper. And also this way. So I'm going to do the same thing here. So that my paper can become the ruler and I don't need the ruler anymore. Now again, you don't have to do 1 inch. You can do whatever length you want. So let's come to our line here. And let's come to our line here. Okay, and that is our right angle. Now what we want to do is we want to draw the hypotenuse. The hypotenuse is always the line that goes across from the 90-degree angle of a right triangle. So I'm going to use my ruler here, but again, you could use the edge of paper to connect these two ends. to give ourselves a right triangle. And if you remember, this is 1 inch, and this is 1 inch as well. Okay? Now the idea behind this is that we are going to draw continuous side of 1 inch while always using the other newly created side. So for example, I have now created a side here that's not 1 inch anymore. That's my hypotenuse, and that's going to be the length of my new second side, where the first side is still going to be 1 inch, if that makes sense. Okay? So with that said, let's do that. Let's make a new 1 inch going this way, keeping this as my new side, my new length of side. And again, I need it to be at a 90-degree angle. So I'm going to use my little tool that I created here. You can see that the hypotenuse is bigger than 1 inch. Looks like it's about 1.5 inches, maybe a little.
It's actually 1.4.
More. And then at my 90-degree angle, I'm going to make a new 1 inch at a 90-degree angle. Okay? So this again is going to be 1 inch. This is again 90 degrees here. And now I have a new length there. I'm going to draw that in. Oops, my ruler moved a little bit. Sometimes that'll happen. Okay, so now I have 2. Now I'm going to again continue working outward and draw another 1 inch using this as my second leg. Okay, so again, I'm going to take my tool that I created, and I'm going to draw from this point another 1 inch out. Here's my right angle. Here's my 1 inch. And then I'm going to use my ruler to connect the hypotenuse. From here to here. Hopefully I don't slip this time. Okay? And then I'm going to continue doing that again. You see how that would work. One more time. I would do this, then connect, then do this, then connect. And what it should end up doing is making a swirl all the way around. And it's called the Pythagorean squirrel, or the Pythagorean snail, sorry. And the interesting thing about the Pythagorean snail is all the hypotenuses are always a square root of the next number up. So this one will be square root of 2. This one will be square root of 3. This one will be square root of 4, or 2 inches, and so on and so forth. So that's what makes it special. So your challenge.
I got ahead of myself. I want to tell you what the challenge is. Your challenge is to do the same thing, to continue that pattern until it goes all the way around and meets with the original line so that it makes this beautiful looking snail shell, and then color it in. Make it beautiful. I'm going to show you mine tomorrow as well so you can see what it looks like. All right. I hope that made sense to you. I hope that you have fun with it. I hope you create some beautiful masterpieces. And as always, I hope you make connections and have a beautiful day. All right, everybody. Happy mathing.